This is lesson 5 for week 3 in statistics and probability, solving for the mean, variance, and standard deviation of discrete probability distribution. With learning competency, interprets the means and variance of a discrete random variable and solves problems involving mean and variance of a discrete random variable. The variance and standard deviation are measured of spread or variability. This is high if the values of the variance and standard deviation are high. That means that the individual outcomes of the experiments are far relative to each other. In other words, the values differ greatly. And it is low if the variance and standard deviation are low. That means that the individual outcomes of the experiment are closely spaced with each other. In other words, the values are almost the same values, or if they do differ, the difference is small. As a point of reference, if the values of all the outcomes in an experiment are all the same, the variance and the standard deviation are both zero. But of course, this rarely happens in real-life application. Let's try to study these two graphs. We have the first graph wherein the grade is from 75 to less than 100 of the students from 0 to 250. And the grades for the second graph is from 80 to more than 90 of almost 250 students. So the first graph has values that are more scattered than the second graph. And the data in the second graph is more closely, tightly packed together compared to the first graph. This means that the variance and standard deviation of the first graph should have values greater than the variance and standard deviation of the second graph. For example, in a 5-item test, the probabilities that a student gets 0, 1, 2, 3, 4, or 5 mistakes are 3 over 20, 5 over 20, 7 over 20, 3 over 20, 1 over 20, and 1 over 20 respectively. What is the average number of mistakes that a student makes in this class? What is the variance and standard deviation of this discrete probability distribution? So first, we're going to make a table of values for the given in the given problem. So we have here a column for the number of mistakes, which is x, and we have the probability of mistakes from P of x. So from the number of mistakes or the values of x, we have 0, 1, 2, 3, 4, 5, and we have the probability from 3 over 20 to 1 over 20. Then we're going now to complete the table by writing another column for the product of x and the probability of x. That means we're going to multiply the value of x, which is 0, times 3 over 20 is equal to 0. Then multiply the value of x, which is 1, times 5 over 20 is equal to 5 over 20. 2 times 7 over 20 is 14 over 20. 3 times 3 over 20 is equal to 9 over 20. And 4 times 1 over 20 is 4 over 20. And 5 times 1 over 20 is equal to 5 over 20. To find for the mean, we're going now to get the summation of the third column. So the sum is 37 over 20, or that is equal to 1.85. That means 1.85 is the value of mean. So for the fourth column, we're going now to get the difference of the values of x and the value of mean. That is, the value of x here is 0 and the value of mean is 1.85. So 0 less 1.85, we have negative 1.85. And 1 less 1.85 is equal to negative 0.85. 2 minus 1.85 is equal to 0.15. And 3 less 1.85 is equal to 1.15. 4 less 1.85 is equal to 2.15. and 5 less 1.85 is equal to 3.15. And for the fifth column, we're going now to square the values obtained from the fourth column. That is negative 1.85 squared is equal to 3.4225. Negative 0.85 squared is equal to 0.7225. 0.15 squared is equal to 0.0225. 1.15 squared is equal to 1.3225. And 2.15 squared is equal to 4.6225. 3.15 squared is equal to 9.9225. And for the last column, we're going to multiply the value obtained from the fourth column to the probability of x, which is in the second column. So that is 3.4225 times 3 over 20 is equal to 0.513375. And 0.7225 times 5 over 20 is equal to 0.18625. 0.0225 times 720 is 0.007875. 1.3225 times 3 over 20 is equal to 0.198375. And 4.6225 times 1 over 20 is 0.231125. And 9.9225 times 1 over 20 is equal to 0.496125. So to get for the variance, we're going now to get the sum of all the values on the sixth column or the last column. So the summation of this is equal to 1.6275, which is the value of the variance. So again, our answer, the value of mean is 1.85 and the variance is 1.6275. So to find for the value of the standard deviation, we're going to get the square root of the values of the variance, where in the value of the variance is 1.6275 and the square root of that is equal to 1.2757350822, or that is approximately or rounded to 1.28. So the standard deviation is 1.28. So therefore, the mean or expected value on the number of mistakes a student may have in a 5-item quiz is 1.85. Again, we emphasize that none of the students actually got 1.85 mistakes. However, if we are to take the average of the total mistakes done by each of the students, we should get an average value of 1.85. Number 2 example or problem. In a seafood restaurant, the manager wants to know if their customers like their new large oyster. According to their sales representative, in the past 4 months, the number of oyster consumed by a customer along with corresponding probabilities is shown in the table. Compute the mean, variance, and standard deviation. So we have here the table, the number of oyster consumed, which is the value of x. We have 0, 1, 2, 3, 4. And the probability of x is 2 over 10, 2 over 10. For 2, we have 3 over 10. For 3, we have 2 over 10. And for 4, we have 1 over 10. So to find for the mean, variance, and standard deviation, so we're going to complete this table. So we have again column for the product of x and the probability of x, that is 0 times 2 over 10 is 0. 1 times 2 over 10 is 2 over 10. 1 times 3 over 10 is 6 over 10. 3 times 2 over 10 is 6 over 10. And 4 times 1 over 10 is 4 over 10. That is 4 over 10. Then, to find for the mean, we're going to get the summation of the product of x and p of x. So that is 18 over 10, or that is 1.8. So therefore, the value of mean is equal to 1.8. Then we have now for the fourth column is the difference of the values of x and mean. That is 2 or 0 minus 1.8. This is negative 18 over 10 or negative 1.8 Then 1 less 1.8 is negative 8 over 10 or negative 0.8. Then 2 less 1.8 is 2 over 10 or 0.2. Then 3 less 18 over 10, we have 12 over 10 or 1.2. Then we have 4 less the mean 1.8 is equal to 22 over 10 or 2.2. Then next, we're going to square the value. So that is 1.8 squared is 3.24. Negative 0.8 is equal to 0.64. 0.2 squared is 0.04. 1.2 squared is equal to 1.44. 2.2 squared is equal to 4.84. Then after that, we're going to multiply now this to the probability of x, that is 3.24 times 2 over 10 is equal to 0.648. Then we have 0.64 times 2 over 10 is 0.128. And 0.04 times 3 over 10 is 0.012. And 1.44 times 2 over 10 is 0.288. And 4.84 times 1 over 10 is 0.484. So to find for the variance, add all the product for the last column, and that is equal to 1.56. So therefore, the variance is 1.56. So again, to find for the standard deviation, we're going now to get the square root of the value of the variance. So that's 1.56. And the square root of that is equal to approximately 1.25. So to interpret the result for the mean variance and standard deviation, based on the computation, the mean of the distribution is 1.8. This implies that the average number of oysters ordered by a customer is 1.8 oyster. Again, none of the customers actually ordered 1 and 8 over 10 of an oyster. The number 1.8 is just the best estimate of the average number of oyster consumed by a buying customer. The variance is 1.56 oyster squared, while the standard deviation is about 1.25 oyster. So this is the main advantage of a standard deviation over the variance. The standard deviation is the same unit as your random variable, while the variance isn't. For example, number 3, the probabilities that 4, 5, 6, 7, 8, 9, or 10 accidents happen in Northern Luzon Highway in a year is 0.45, 0.22, 0.15, 0.10, 0.05, 0.02, and 0.01 respectively. Find the average number of accidents that occur in the said highway each year. So this is the table for the accident and the probability of the accident. So to find for the mean variance and standard deviation, let's compute for the third column, that is multiplying the value of x and the probability. That's 4 times 0.45 is equal to 1.8. 5 times 0.22 is equal to 1.1. 6 times 0.15 is equal to 0.9. 7 times 0.10 is equal to 0.7. 8 times 0.05 is 0.4. 9 times 0.2 is 0.18. And 10 times 0.1 is equal to 0.1. That is 10 times 0.01 is equal to 0.1. So to find for the mean, add all the products. So we have now 5.18, which is the value of the mean. And for the fourth column, we're going to subtract the mean to the value of x. That is 4 less 5.18 is negative 1.18. 5 less 5.18 is negative 0.18. 6 less 5.18 is 0.82. 7 less 5.18 is 1.82. 8 less 5.18 is 2.82. 9 less 5.18 is 3.82. And 10 less 5.18 is equal to 4.82. Then square the result for the fourth column. That's negative 1.18 squared is equal to 1.3924. Negative 0.18 squared is equal to 0.0324. 0.82 squared is equal to 0.6724. 1.82 squared is equal to 3.3124. 2.82 squared is equal to 10.9524. 3.82 squared is equal to 14.5924. And 4.82 squared is equal to 23.2324. Then after that, multiply again this to the probability of x, that is 1.3924 times 0.45 is equal to 0.62658. 0.0328 times 0.22 is equal to 0.007128. 0.6724 times 0.15 is equal to 0.186. 3.3124 times 0.10 is equal to 0.33124. 7.9584. 9524 times 0.05 is equal to 0.39762. 14.5924 times 0.02 is equal to 0.291848. And 23.2324 times 0.01 is equal to 0.232324. So to get the variance, add all the product and for the last column, so that as the summation is 1.9876. So therefore, the value of the variance is 1.9876. So the mean is 5.18. The variance is 1.9876. So to find for the standard deviation, we're going to get the square root of the value of the variance, which is the square root of 1.9876, which is equal to approximately 1.41. So based on the given data, the expected number of accidents that will happen in the Northern Luzon Highway is 5.18 with a standard deviation of approximately 1.41. So for your activity, you're going to solve and interpret the results of the following problems. So we have problem number 1, wherein given the table below, and for number 2, we have also the table below. So you're going to solve and interpret the result. Then for reflection, what lesson you've learned from this topic. So again, let me share the quotation of Taleb. So we have the Taleb quotes. Failure saves lives. In the airline industry, every time a plane crashes, the probability of the next crash is lowered by that. The Titanic saved lives because we're building bigger and bigger ships. So these people died, but we have effectively improved the safety of the system and nothing failed in vain. Again, this is teacher Riza. Please follow the health protocol and stay safe always. That's all. Have a nice day. Thank you.